Hello everyone. Today we are going to be presenting our NAE project, dealing with making solar energy more efficient. My name is Mariano Fuentes, and to start off, we will talk about the goal of our code, which was to use uh, the Harpoon project to get a set of metal alloys uh, that would be used as catalysts for oxidation. Okay. Uh, to continue this presentation, I will pass on to Roshdi, who will explain the Harpoon project.
Hi everyone. I'll be explaining the Harpooner project how it goes. Um, our data is based on the an experiment going right now going in the laboratory for chemical engineering. So it's discovering an expensive effective catalyst for solar energy conversion. So basically, the experiment is mixing three metals into a beaker like this, and then this metal mixture will go into a sheet of paper like this, having dots in there, and we're gonna put in a device, and there's a camera and a light, and after that, we're gonna get these sheets right here, and each spot, as you see, it's demonstrating how much light is absorbed in this location. So the darker the light, the more efficient that catalyst or that metal it will be for our solar energy conversion. I'll be passing this to Jubin.
Hello, everybody. My name is Jubin Joseph, and I'll be presenting the data aspect of this NAE project. As seen on the screen right now, this is like a CSV file that shows all the data that we received from the Harpoon people. So, in this situation, as Roshdi was explaining, at each individual spot, there's going to be like a certain different alloy, and it shows like the activity level as based on the last column. So it says a solution, the spot, and it shows like the metal composition of that day. So we've got 3 different days of data. We got October 1st, 2019 data, October 2nd, 2019 data, and we got October 10th, 2019 data. So for each of these days, we got different metal alloys. So for October 2nd, 2019, as shown on the screen, we got copper, silver, and zinc. And based on like the spot and the solution, there will be a different composition of those metal alloys. So for the first spot, A2, it says a composition of 100% copper with 0% AgNO3 and ZnNO3, and this produced an activity level of zero point 0.6. So this is how they did the testing based on like the first pictures that you saw of which one was the most effective at those points. This is how the data was calculated, and then this is the data for October 2nd. This is going to be the data for October 10th, which contains rubidium, cesium, and potassium. And this is going to be the data for October 1st, which shows nickel, barium, and chromium. And to do the demonstration of the code, I'll be passing it to Andrew.
Hey everyone, my name is Andrew. I'll be demonstrating you our code. So we'll go up here and we'll click run. You'll be able to select the date of the experiment you'd like to evaluate the oxidation activity. So let's go and select October 2nd. And what that outputs is a graph displaying the activity as well as the spot location. It also displays the average as a solid line here on the graph. As you can tell, the average activity was 0.69. If you look down here in the command window, it also outputs which catalysts were tested, as well as the maximum oxidation activity, which on this data is 1.87. It also outputs the locations of that oxidation activity. So for this experiment, the location was spot 16, 31, 46, and 62. It also outputs the ratio at those spots. So you can see it was 6 copper, 6 silver, and 88 zinc. Then it allows you to select if you'd like to evaluate another experiment. We'll go and try it again. And this time we'll check out October 10th. Again, it has the same output. with that graph, and then also it outputs the same or different data, but in the same format for that date. And then over here, we can select if we would like to run another experiment. We're going to click. We're going to go and click no this time. Then over here, if you look down here, it outputs of the experiments evaluated. Shows that the experiment performed on October 10th had the maximum oxidation activity of 1.99. It also shows the experiment with the highest average, which for the experiments evaluated was October 1st. I think that this makes our program great in that since Harpoon is an ongoing project, we'll be able to use it to continue to evaluate data into the future. And then with that, I'm going to pass it off to Khoa to summarize our project.
Hello, everyone. My name is Nguyen, and I will be presenting our conclusion to our project. So, as you all know, that each and every single project that we're having right here, they all have its own limitation. And for our part, our limitation is that this is an ongoing research. So, all the data we are presenting right now is very limited, and it's very hard for us to retrieve those data. And also, according to the Harpoon people, there are 22 metals in total to be tested, and there are only 9 catalysts so far that we're having in our code. So that's our biggest limitation in our code, and our given data is very specific in terms of having metal, and there are only 3 metals that presenting to all of you in our code. And thank you to people from National Science Foundation Center for Chemical Innovation in Solar Fuels that help us in presenting all the data for this NAE project right here. And thank you all for listening to our presentation. I hope you have a good day.